Okay, guys, here's the second example, just in case anyone feels like they need one more, of the three variable systems. Okay, so here we go. Again, we want to accomplish a two variable system, and we have to do that by eliminating one of these variables from the beginning. When I look at this, I have 2, 3, 5. I'm going to have to multiply everything all the time. So that's probably not the best situation. I have 4, 5, and 3. Probably not the best. Again, if you see something like this where one of them has a 1, that's probably the ideal situation for that being the variable to eliminate because it just is going to be a little bit easier to get rid of. Again, is it always going to be one of them where it is a 1? Absolutely not. But if it is, that's going to be the easiest situation. So that's what I'm going to focus on, eliminating Z. All right. So since I'm going to focus on eliminating Z, again, I need to eliminate it in pairs. So the equations I'm going to pick, I know I'm going to use this bottom one because that's the one with the 1. That'll make it easy to multiply. So I'm going to do, let's say I'm going to go with the top equation and I'm going to go with the bottom equation. All right. So let's look at the top one. We have 2x plus 4y minus 5z. Again, it's very critical to copy the equations right with these three variable systems. If you copy anything wrong, it's a whole lot of work to have to redo. And, during quizzes and tests, it's pretty much, you know, unreversible to lose that much time doing the three variable system incorrectly with the wrong numbers. So it's a very simple thing. You want to just always double check them. All right, because it's easy to like pick a number from here and versus there, etc. So again, I'm going with I said equations 1 and 2. I'm sorry. I'm going with equations 1 and 3. My apologies. All right, so again, I'm going to eliminate Z. So since eliminating Z is what I'm trying to do, this is the multiples I'm going to focus on. I already have a -1, and this one is a 5. So I'm going to keep this one, just going to keep it the same. So I'm going to multiply by 1 or basically leave it alone. Nothing to do there. Minus 5z equals 18. Now this one, I want to be a positive. Again, that doesn't have to be your goal. I like to get them to be opposites immediately so there's no confusion as to whether I'm adding or subtracting. So in this case, I want to get a positive 5. So that means I'm going to multiply by a -5 because a negative times a negative will give me the positive. And again, I multiply everything, even the 17, even the -17, everything gets multiplied by that -5. All right, so I'm going to end up with 25x minus 15y plus 5z and plus 85. All right, again, they're opposites, so I know I can just add them up. So let's simplify that. When I simplify that, I end up with 27x minus 11y. The z's cancel, equals, that's going to be 103. All right, so this is my first equation with only two variables. Now, again, I'm still focused on that eliminating z thing. All right, so eliminating z here. Again, I'm going to always use this bottom one because that's the one with the 1. So I'm going to keep equation 3. And the other equation I have to use this time is going to be equation 2. So those are the two I'm going to use. So it's going to be negative 3x plus 5y plus 2z. Again, double check the equations before you start the math. If you have a negative instead of a positive, one little thing, it's all going to be wrong. All that work, you don't want to waste your time. Plus 3y minus z equals -17. All right, so now I'm going to focus on, again, eliminating the z's. So right now I have a positive 2 and I have a -1. What's going to get those to be the least common multiple? It's going to be 2. Again, the top one I'm not doing anything with, keeping it the same. Plus 5y plus 2z equals -27. The bottom equation, again, I want opposites. It's already negative, but I still need a 2. So I'm going to multiply by 2. So I'll get -10x plus 6y minus 2z equals negative 34. Add them up, bring them together. So at this point, sorry, move down a little bit. I'm going to end up with negative 13x plus 11y. My z's have canceled, equals negative, what's that, 61? 61. So these are my two equations. Hold on. KJ, be quiet. I'm recording. Be quiet. I'm recording. You're too loud. I'm sorry. It's being obnoxious downstairs. A little too loud. Alrighty, so now I'm going to take these two equations, and now I have the two variable system I need. So my two variable system is going to be, just going to move that up for space, 27x minus 11y equals 103. Do not like these numbers. Negative 13x plus 11y, oh, praise God, they're already opposites, equals negative 61. Didn't even notice till now. All right, so now we have the two variable system here. Now, hopefully you guys just noticed like I did, these are already opposites, so all we have to do is add them up and everything's going to be fabulous. So 27 minus the 13 is going to be 14x. My y's are gone, equals, what's 42? 42. Divide that by 13, or sorry, 14. And we're going to get x equals 3. That worked out good. All right, great. So now that we have one of the variables, we start the substitution process. Substitution. Our first step of substitution is going to be plugging into one of the two variables because we only have one of the two. I'm going to go positive at all times. So 20x, oops, 27x. 27x minus 11y equals 103. So 27 times 3 minus 11y equals 103. That is 81 minus 11y equals 103. Subtract the 81. So that's going to leave us with negative 11y equals 22. Divide that by negative 11. And we get y is negative 2. All right, we're doing pretty good. So we got 2. And now we want to go back and get the third variable. Again, there's no third variable with the two variable system. So we have to go all the way back to one of the top two equations. Now, I just forgot, forgot my answers. Excuse me, I got x and y, whatever. All right, so I'm going to plug in. Doesn't matter which one. I guess I'll go with the first one. That looks a little easier to me. So again, now I'm substituting into one of the three variable systems from the beginning. 2x plus 4y minus 5z equals 18. All right, I just forgot what I got for my answer. Okay, I had x is 3, sorry. I had x is 3, so 2 times 3, plus 4 times negative 2, minus 5z equals 18. All right, so that's 6 minus 8. Negative 2 minus 5z plus 2, just for space, negative 5z equals 20. And we get z equals negative 4, guys. All right, again, we'll write our answers as an ordered triple. So ordered triple, sorry, just for space. Here's my ordered triple. And again, it's x, it's normally alphabetical. So x, y, and z, not normally alphabetical, but again, sometimes it's not x, y, and z. So those are our three variables. All right, again, I'm putting up 3 for the homework. Maybe I'll do 2, but hopefully this helped. Have a great day. Have a good weekend, guys. Bye.